reflection. So by now you guys know whenever we are adding something to the function or whenever we are adding something to x, our graph is just shifting. Either it's moving up or down or left to right or both. Okay, that can also happen. We'll talk about past paper questions, then you guys would get a better understanding of everything. Okay, then after translations, yesterday we discussed reflections. And in reflections, again, we had two cases. For case one, minus was being multiplied with the entire function. So for that case, x-axis was the line of reflection, but the other case was when we multiplied x, when we multiplied minus with x. So there y-axis was the line of reflection. And I've been telling you guys, things at times would seem to be other way around, but you need to keep all of this in your mind. Okay, so these were the two types. Today we will be talking about the next type of transformation, and that is stretch. Okay. All right, so let's talk about that. And if you guys have anything that's coming to your mind from the previous two types, you're more than welcome. You can ask me right now. You can ask me later on, whenever you feel like. Okay. All right, so let me just start off with this thing. All right, it's basically the 7th unit of this chapter, 2.7, and it is called stretches. Let's understand this now. Okay. Again, let's talk about two examples. Example number 1 says you have y equals to x squared minus 2x minus 3. And then you have y equals 2 multiplied by x squared minus 2x minus 3. Now, what is the difference? This time around, we have multiplied a number with the original equation. Okay. We know what happens when we are adding, subtracting to it. We know what happens when we multiply -1. And this time around, I'm not multiplying any other number. I'm not multiplying -1. It's just a number that is true. So yes. Let's see what impact it would make on the graph. Let's talk about that now. Okay, so this is my y-axis. Here is my x-axis. Okay. Now, first of all, I am going to make the graph for the original one. It's 1. And then this is equation number 2. Okay. Let me make the graph for 1 first. So it is going to be something of this type. Okay, I've just made the graph, and you guys know how we make these graphs by factorizing this thing, and then we find the x-intercepts and then y-intercept, and that is how this graph is made. Okay, forget that. This blue graph is basically the graph of equation 1. After multiplying 2 with this thing, what would happen to the graph? The graph is going to stretch. Okay, now imagine that you are going to hold this graph and you will just pull it downwards. You will just stretch it downwards vertically because this 2 was multiplied with the function. So there would be a vertical stretch. And just imagine that this was an elastic string out of which I made this graph, and you're just pulling it down. So what would happen? The new graph is going to be something of this type. Okay, now the best thing is that for this one, you guys can try finding out the x-intercepts, and you'll see that the x-intercept for the first one and the x-intercept for the second one would be same. That is why this point and this point is same. Okay, automatically you know that when you will equate 1 and 2 to 0, this 2 would make no difference. You'll take this 2 on the other side and it would just, it would be divided by 0, and every other thing would be same. So the x-intercepts are going to remain same, but overall it is going to be a stretch. So best way to understand is that imagine it is a string, the blue one, okay, and it was fixed at these 2 points somehow. And then when you will pull this one, when you will pull this blue string, you would get the red graph. Okay, every part is correct. The red part would obviously, when you will pull it, where it would be a stretch, it is going to be over here, right? It won't come like this. No, because we are stretching it, we are not making it again. That is why it is like that. Yes, any confusions with this?
No, miss.
No, ma'am.
Okay, all right, perfect. Let's talk about the other scenario then. Let me just write down a key point that we'll be using directly. And tomorrow we'll be talking about past paper questions from this section. Okay. It says the graph of y equals a multiplied by f of x is a stretch of the graph y equals f of x with a stretch factor a along or parallel to y-axis. Okay, now I'll tell you. You guys know so far that whenever something would be added or subtracted, either in the function or in x, it would be translation. That is enough. But you need to use this key point to answer examiner, okay? This has a mark and then this has a mark, okay? It is a translation of the graph, and then you need to tell the translation vector, okay? Similarly, when we discussed reflections, you need to tell that it is a reflection and then the axis as well, that if it is a reflection in y-axis or x-axis, so both these encircled things are important, okay? And then the third type, that is stretch, basically here you again need to tell if it's stretch, if it's translation, if it's rotation, if it's stretch, and then you need to tell if it's along the y-axis or x-axis, and it would be along y-axis when you are multiplying something with the function. That makes sense as well, okay? This one would make some sense, but you'll just see something in bit. Okay. All right. Now let's talk about example 2. So we have two equations. The first one is y equals x squared minus 2x minus 3. And then the other one is y equals 2x squared minus 2 into 2x minus 3. Okay. Now one might say that both of these equations are quadratic, and you guys know how to make a quadratic equation, how to plot a quadratic equation or how to sketch a quadratic equation. That's true. But the examiner would want you to make both the sketches on the same graph, and for that you need to understand the idea. Okay, you won't be given any grid or something of that type, so you would not be able to that precise. You only need to show him that if it's a stretch, it should genuinely look like a stretch. If it's reflection, it should look like a reflection, and if it's translation, so yeah, that would be obvious anyway. All right, okay. Let's make the graph on this side then. Now what has happened? We have multiplied a number with x. Okay. Now you will be a bit surprised to see this thing. Let me make the blue graph again. Okay. This is basically the graph of equation 1 or the original function. Okay. After multiplying 2, now we know that obviously if we are multiplying something with 2, the stretch would be along x-axis. But what do you guys think? Let me make two graphs for this. Would it be something of this type? Yes, because it's a stretch. What do you guys think? Any idea about this one? When we are multiplying a number by 2, obviously when we were multiplying the function with 2, there it made sense that the stretch was along y-axis and we just pull the string down. Okay, now we are multiplying 2 with x, so the stretch would be along x-axis. But I have been telling you guys already, for x things have always been very different. Okay, when you will be multiplying 2 by x, it would, yes, you'll call it a stretch, but it won't stretch. The graph would basically shrink. It is not going to stretch, it would shrink. And when I will multiply 1 by 2 with x, then in that case, it would actually look like a stretch. Okay, so it's other way around. Let me just make the graph of this one, and then I'll explain the idea about it. So it is, yes, this is going to be the graph of equation 2. This is equation 2. And the blue one is the graph of equation 1. Now I'll tell you, okay? Please pay attention. When we multiply 2 with the entire function, that looked like an actual stretch, and we just stretched that thing along y-axis. That made sense. We guys are used to, dealing with strings and stuff like that. So we know how things would have been for that one. This time around, this is something that we were not expecting. When you will multiply 2, 3, 4, 5, a proper number, a whole number with x, your graph is actually going to shrink, and you will get to see that once I write down the key point. Okay, it has actually shrinked, and when I will multiply a fraction with it, there you will actually get to see the genuine stretch. But I would like to emphasize on a few points here. Number one, here again you can see that both these points are same. Okay, for reflection and for translation, things were not complicated. That was very easy. We were just reflecting and we were just picking up the graph and moving it here and there. But for stretch, you need to be precise about a few things. Again, please focus at this point. When I made the stretched version of the blue graph, I need to be sure that my y-intercept is going to be same. Okay, this time around, the stretch was along x-axis. It was not along y-axis. If it was along y-axis, it would have been something of this type, right? Not exactly this type. We have just studied that thing, but you guys get the idea. However, when it would be along the x-axis, things would be opposite. And for x-axis, y-intercept has to be same. And when the stretch was along y-axis, you guys can see, we made sure that this thing and this thing stays same. Okay, so the x intercepts were same for both the graphs when the stretch was along y-axis. Okay, this time around the stretch was along y-axis. These things are important. Let me write it down. Stretch along y-axis and x-intercepts for both the graphs are same. If I talk about the second case, stretch along x-axis and y-intercept is same. You guys will get obviously these notes, so this would help you with the understanding about the idea. And I agree things would, they would get better once we do past paper questions. This is not difficult at all, but it is confusing. So yes, that is the idea. All right, okay. Anything that's coming to your mind, all of you, please feel free to ask me. Munja, Mutasam, Ahmad, and Rafe.
No, Miss, everything's clear.
What about
Okay.
if it's negative, ma'am? Are we
Mhm.
going to do that? Sorry.
Yes.
2x squared. What about if it is a negative? How does it stretch?
Yes, that is a good question. We will obviously talk about those cases once we go to the past paper question, right? But
Okay.
for
Thank you, ma'am.
minus 2x, you'll see minus would basically cause reflection, and this 2 would actually stretch that reflection, right? So you
Yes.
will imagine that thing this way. Let me answer this here as well. You are talking about this third scenario that, let's say, if we multiply x with, I think this was your question yesterday as well, right? Minus 2x minus 3. Imagine that this is the thing, right? Is this your question, Munja?
Yes. Yeah. Yes,
Okay.
ma'am.
Okay. All right. So we have two things now. We know that this minus is going to cause a reflection, and this 2 is going to stretch that. Okay. So let me go back to reflection. Here is reflection. Okay. Whenever we have minus with x, it would reflect in the y-axis. Okay. So this was the scenario. The blue graph was original, and it is going to reflect in the y-axis. So the graph would be, let me just make it now. It would be a reflection in the y-axis. So it is going to be something of this type. Okay, I've just reflected that using, I know it's not perfect, but I have just made the reflection of the blue graph along the y-axis because minus was with x. Okay, I know things are complicated, but just take 15 to 20 minutes, keep every point in your mind, and then things would get clear. Now I will think about it this way, that okay, now this is my graph, and now I'm multiplying 2 with x. So then when you will multiply 2 with x, that is actually going to be a stretch along the x-axis, and it is basically going to shrink. And if you don't want to think about it this way, think about it this way. This is better. Okay. This was the original case, and then you multiplied minus 2 with it. Okay, so just make this one, that was the red graph, and for this minus, now you can directly just reflect that along the y-axis, the red graph. Just find the reflection of the red graph along the y-axis, and then you would get the required graph, right? So basically for such cases, we would be having multiple transformations involved, and you will certainly, like, we will only get to see those questions where multiple transformations would be involved. Okay, you need to be good at it. And if it's minus, it's reflection. If it's a number being multiplied, it is stretch. If it was a number being added or subtracted, that was translation. Okay, yes, Munja, understood?
Yes, ma'am.
Okay, all right, perfect. Now let me erase this thing, and let me just write down that key point, and then you guys would be able to understand things well. Okay. All right. So here it is. Okay. Now please pay attention. This key point says the graph of y equals f of ax is a stretch. We don't write it down that it is a string. It is certainly a stretch, but you'll see something would be happening in the stretch factor. It is a stretch of the graph of y equals f of x with a stretch factor one by a along x-axis. Okay. All right. Okay. Now it's ax. You have multiplied the number with x directly, so it would certainly be along x-axis. But the stretch factor was not a, and you guys were able to see that thing as well. The stretch factor was 1 by a. That is why when we made this red graph, it actually shrink compared to the blue graph, right? So this is the idea for stretch. Whenever a number would be multiplied by x, it could be 2, 3, 4, 5, it could be negative number as well. For now, we are considering positive integers. It is not going to actually stretch. It would stretch, but by a stretch factor of 1 by a. So this time around a was 2, this is a. And when we made the graph, we can actually see that the red graph stretched by a stretch factor of half. So basically the graph actually did not stretch. It's shrinked version of how it actually was, right? Yes. Anything that you guys are not able to understand, please tell me.
Makes sense now.
Okay. Rafi, Ahmed, and Mutassim.
So if it was like 1/2 and 1/3, etc.
Yes, very good.
The stretch factor will be like a along the x-axis, right?
Very good. Excellent. The stretch factor is 1 by a. So if a is 1 by 2 or 1 by 3, the graph would actually stretch by 2 times or 3 times. So for that, let me make that as well. Okay. Let's consider the same scenario. Example number 3 for this one. Now the original equation is y equals x squared minus 2x minus 3. And now I'm going to multiply 1 by 2 with x. Okay. This one is 1. And this one is 2. And what is the thing? The thing is that now we have 1 by 2 here. Now we have 1 by 2 here. So a is 1 by 2. And the stretch factor is 1 by a. So it implies the stretch factor is 2. Okay. Let me make the graph for this scenario. All right. Okay. So imagine that not this. This was the graph for the original thing. Okay. The yellow one for the first equation. Now, if I make the graph for this one, for the new equation where we multiplied 1 by 2 with x, it is going to be one second. Someone's mic is unmute. Please keep your mics muted. I'm not sure whose mic it is. Mutasam, please mute your mic. Okay. I know it's not that perfect because of my drawing, but you guys get the idea. Now the red graph is basically for equation 2. And what is the difference in the second example and in the third example? Here we have multiplied 1 by 2 and you can actually see stretch. And again, this thing is same. Okay, this has to be same. This has to be same. Let me just make it one last time. Should be a bit better than this. Something of this type. Okay, but the red graph is actually bigger than how it actually initially was. And another thing is clear that when we are multiplying 1 by 2 or 1 by 3, the graph is actually stretching by stretch factor 2 or 3. Okay, so things are opposite for stretch when it's about x. However, when we were talking about a stretch along y-axis, when a was being multiplied, the stretch factor was a. And you could see that thing as well. Blue was the original graph, and when we multiplied 2 with the entire function, I've just pulled the blue string down, and the red graph would actually be the stretched version of how it actually was, right? Is it okay, Rafe?
Yes, miss.
All right, okay, perfect. Let's talk about some questions. Okay, now it says the graph of y equals 5 minus 1 by 2 x squared is stretched with a stretch factor of 4 along y-axis. Find the resulting equation. Okay, this is basically the question. So this is the usual graph. It's basically equation number 1. This is how we were actually doing these questions. It was y equals 5 minus 1 by 2 x squared, and then it's stretched with a stretch factor of 4 along y-axis. Now, when things are along y-axis for stretch, it is actually going to be genuine. Okay, we know that if it is y equals f of x, after stretch by a stretch factor of a along y-axis, it becomes y equals a multiplied by f of x. So if I talk about the solution, it is y equals 5 minus 1 by 2 x squared, and it would become y equals 4 multiplied by 5 minus 1 by 2x squared. That is y is equal to 20 minus 2x squared, and this is going to be the answer. Please keep your mics muted. Mutasam, please keep your mic muted. 1 second, please. All right, okay. Any confusion with this example? Anyone? Any query?
No, miss, everything's clear.
Okay, all right, perfect. Okay, the next question is for you guys because this is how exactly the exam questions are going to be. Please try doing it. Give it a try. It's not difficult at all. Question number 2. Describe the single transformation that maps the graph of y equals x squared minus 3x minus 5 to the graph of y equals 4x squared minus 6x minus 5. Okay. So describe the single transformation, a very important keyword. If the transformation would be single, the examiner would write that. And at times, in fact, most of the times, the transformation would not be single. Multiple transformations would be done, and then you would get that end product. Okay. That maps this graph to this graph. Okay. Think about all the transformations that we have been talking about. Translations, where we were adding and subtracting a number. Then we discussed reflections when we were multiplying minus sign. And then last was stretch that we have just done. Okay. Yes, please do it. And you guys know how to describe it, right? You need to write down the name of that transformation. And if it's translation, then the translation vector. If it is reflection, then along which axis. And if it is stretch, then the stretch factor. And if it's along x-axis or y-axis. So I'll mute myself and please think about it and then tell me the answer. All right, let's try doing this question. Now, obviously, this made sense that it would be stretch because this time around, we are talking about the third type and this question is coming from the same unit. But when the examiner would ask you, it could be any transformation, okay? So far, we know it could be translation, it could be reflection, it could be stretch. Okay, we know these three transformations. Okay, we have -5 here and we have -5 here. So certainly we did not add or subtract anything in y. Okay, but did we add subtract something in x? No, because if we were adding or subtracting something in x, then after the overall expansion and everything, this figure would have changed as well. Okay, because for example, let's say if it was x plus 1, I'll quickly do this. But I will expand this entire thing. And again, when I will get this type of thing, you will clearly see that this would not be -5. Then I would have this one, I would have this one, and then this number would change, right? So the fact that this number and this number, both of them are same, means that it is not a translation. Almost certainly, okay? -5 and -5 is same. It's not a translation. Okay, so this option is gone. Reflection. What do you guys think? Is it reflection? We had minus sign here. We have minus sign here. Again, minus sign here. And again, minus sign there. So certainly, it is again not a reflection because the signs did not change at least. The signs did not change. Okay, so it's not reflection. Is it stretch? Yes, that's the only type, and it looks like stretch. How? Because originally it was y equals x squared minus 3x minus 5. But if I write down 2, if I multiply 2 with x, I would get the same thing. And now I would get 4x squared minus 6x minus 5. So this was certainly correct. I have multiplied this 2 with x, and this is how I got this. That's clear, okay? But what does this multiplication of 2 with x implies? We know that whenever we are multiplying a proper number, that is basically going to be stretch. So you would get 1 mark for stretch for identifying the correct transformation, and then the second mark you would get by telling the stretch factor. So stretch factor is basically 1 by a. Okay, it's 1 by a, and a is the number that you're multiplying. If I had 1 by 2 multiplied by x, I would have said a is 1 by 2. I have 2x, it means a is 2. So stretch factor is 1 by a, and since a is 2, so it would be 1 by 2. And the last mark I would get by telling if it would stretch along the x-axis or y-axis. Okay, so it would be along y-axis. No, it would be along x-axis. So this is going to be the answer. This is basically the answer. Every other thing was done for your understanding, but you would get mark for this thing only. And this obviously is important for your understanding, just so you guys understand the idea, okay? So for every transformation, we have a few things, and out of these 3 transformations, stretch is considered to be the most difficult one. Yes, anything, Ahmed, Munja, and Rafe?
No, miss, everything's clear.
Okay, all right, okay, then that's perfect. So I'll stop the recording.